Welcome back, everyone. Now that we've covered a summary of looking at redox reactions and comparing electrolytic and galvanic cells, let's go and have a look at some questions that we might want to apply our knowledge to as we go through this revision session. Now, if you look at this typical exam type of question, the first thing is that we're asked to look at the electrochemical cell. Now, you might think, oh, that's a strange term. We haven't often used that term. It's not identifying it, is it galvanic or is it electrolytic? But what we do recognize is that there's a voltmeter here, there's a salt bridge over here. We've got one half cell here, one half cell here. And I think you should be able to recognize, as we look at the diagram, certain information that they're probably going to ask some questions about a galvanic cell. Well, let's go and have a look at the questions. So the first question is, what type of cell is shown? Well, we've already said that this is a galvanic cell. Now, if I had to give you some further question and say, give me some reasons why it's a galvanic cell, what you'd recognize that in this cell, there's no battery. There's a voltmeter in the external circuit. So a galvanic cell is involved in transforming chemical potential energy into electrical potential energy. And because of that, we know it as a galvanic cell after Galvani, who discovered this cell and is the father of modern batteries. So we recognize as well that there's a salt bridge and that there are two cells. So it's definitely a galvanic cell. Next question. Write down the overall net reaction that takes place in the cell when it is working. So we need to be able to identify what's going on here. We've got a silver half cell and we've got a nickel half cell. Now, guys, I don't, at this stage, have much idea in terms of being able to guess which is the more reactive, which is the less reactive, which is the stronger reducing agent, which is the stronger oxidizing agent. To be able to get the values out and to get the proper reaction, I've got to go to the table of standard reduction potentials to compare these two half cells. Now remember, this table of standard reduction potentials was originally calculated because each of these half cells has been compared to the standard hydrogen potential cell, the standard hydrogen electrode. And based on that, we've been able to get quantitative readings of the differences. And that's what's found in our table. So my rule is that I look at the table of standard reduction potentials, and I'm going to start on the right-hand side. I'm going to look for my reducing agent. In other words, I'm going to look at the substance that is likely to be oxidized. In other words, if it's going to be oxidized, I'm looking for my anode. So all of those thinking steps is what leads me to look on the right-hand side here at the metal. And I'm running my finger down the right-hand side, and it can either be silver or nickel. And I haven't seen silver or nickel until I look over there. And that's where I see nickel goes to nickel 2 plus 2 electrons. And so there's no doubt in my mind that this is the reaction at the anode, because that's the oxidation reaction. However, let me go to the next part of the table, and I'm going to carry on going down to be able to see where I might find silver. And if I follow the rule down, I'll see, there's silver. Silver's not going to react. It's not a strong enough reducing agent. But the silver over here is a stronger oxidizing agent. So there's my oxidizing agent. And I recognize that's the reaction I'm going to need to write down. So to answer the question, I'm going to go back to the space that I've got, and I'm going to say, Well, nickel went from the solid to nickel 2 plus 2 electrons. This is the oxidation half reaction. And immediately I'm going to say this is the anode. It's the source of electrons, and so I'm going to make that negative. Now, what about the other half reaction? Well, its silver ions are going to gain an electron to form silver metal. I'm going to indicate that as reduction, because a gain of electrons is a reduction reaction. Remember, reduction takes place at the cathode. And so as I'm building up the answer to this question, I'm annotating on the diagram as well, because a later question might ask me to use that information. It's a very good exam tip to do, to add as much information on the question paper even if you don't write it all down on your answer sheet, but it helps your thinking. And so I'm definitely going to say this is the cathode. And it is positive, because the electrons are going to move from the anode towards the positive terminal. That's the movement of electrons. So in terms of my half reactions, I've not completed the question because it asked me for the net or overall cell reaction. So don't just write down the half reactions and identify them. You've done the hard work. It's important now to complete the job. So the first thing we need to recognize is we've got an imbalance. We've got 2 electrons that were given away and only 1 electron gained. To correct that imbalance, I'm going to multiply this whole reaction by 2. And now the electrons will cancel out, and I'm going to start writing down the net reaction. So I'm going to say nickel plus 2 Ag2 plus. Please write the ions in and recognize that this is an aqueous solution. That's a solid. It's the electrode. It forms nickel ions. And I'm going to put in the phase indicators here, plus 2 silver metal, which are solid. That's going to be deposited onto the electrode. And so there we have the net reaction. And we've been able to use that to identify what's the anode and the cathode as well. So let's go and have a look at the next question. It says here, which electrode, nickel or silver, must be connected to the negative terminal of the voltmeter? Now remember what we said. This is the anode, and it's giving away electrons. So this is the source of electrons. So this must be the negative. This is the positive. This is the positive terminal of the voltmeter. If we connected the voltmeter in the incorrect way, then the reading on the voltmeter would be in the opposite direction. So as long as we connect the negative to the negative and the positive to the positive, we will get a positive reading on the voltmeter. If we connect them incorrectly, it will give us a negative reading. So we want to make sure we connect the voltmeter properly. And so in this case, we have to connect the negative end of the voltmeter to the anode. So that's how we've done it. And so what we're going to say, the electrode must be the nickel electrode. So make sure the nickel electrode is connected to the negative end of the voltmeter, terminal of the voltmeter. Right, moving on. Write down the cell notation for the cell. Now, guys, this is not difficult. It's something that you've got to learn and make sure you stick to the rules. If they say under standard conditions, and they usually do, they want you to indicate the standard conditions as part of the answer. I'm going to put in both the phase indicators and the standard conditions into the answer so that we get it right. So we start with the anode. And we're starting with the electrode, which is nickel, and we're going to say that is a solid. Then we put a line to indicate there's a difference between the electrode and the other phase. And here we're going to say it's nickel 2+ solution, which is an aqueous solution, and because it's at standard conditions, we're going to say it's 1 mole per decimeter cubed. Now you can change the 1 mole per decimeter cubed to molar, that's fine. Double line to indicate the salt bridge, and then we're going to say we want some silver ions, and those silver ions are in aqueous solution, and they have a concentration of 1 molar, and then we get a silver electrode, which is a solid, and we must say at 298 Kelvin or 25 degrees Celsius. So the standard conditions of a galvanic cell are namely concentration of 1 mole per decimeter cubed at 25 degrees Celsius, and if it involves gases, and only if it involves gases, must the pressure of those gases be 1 atmosphere, 101.3 kilopascals. For this cell, we wouldn't need to say the gases for the standard conditions. Right, let's look at the last question for this section. What would you notice about the mass of the electrodes in the cell? Well, clearly at the anode, we're going to find that the mass decreases. So there's going to be less nickel, but at the cathode, we're going to find there's going to be the mass increases. Because silver is being deposited onto that electrode. The silver cathode is going to get bigger and bigger, and the nickel anode is going to get smaller and smaller. Well, I hope you found those questions interesting, and I hope they've helped you revise some of the key points in answering questions about galvanic cells. What you'll notice is that they're quite predictable, and so it's worthwhile taking some time to learn how to answer these questions. Let's have a short break, and after that, we'll come and answer some more questions.